Hey everybody, this is the Test1 review from your online homework. I just printed it off. Your problems might be exactly like mine, or they might be different. It just depends. So, but I would still follow along with me, and I will post pictures of this online, and you can use it to do your own review. For this Test1 review that's online, everyone must do it for at least a 70 in order to take the test. If you do not do this online Test1 review for at least a 70, you will never, ever get to take the test. You will get a 0, and then you will have to wait until the end of the semester for that 0 to get replaced. The only way you will be able to make up, there's no way you can make up the test if you don't do the review for at least a 70. So this review is single-handedly probably the most important assignment. All the reviews are, because if you don't do them for at least a 70 before you take the test, then you cannot take the test. So if I were you, I'd go ahead and get started on it, just so that you have something in there, so that if you run out of time later, you still have something already answered and it takes less time. Okay, so our first test 1 is going to be over 9.1, 9.2, 9.3, and 9.4. So 9.1 through 9.4. And this is pretty much how it's going to be. If you've looked at the calendar, it looks like we, spend 3 weeks learning and then 1 week testing. 3 weeks learning, 1 week testing. Okay, so first, number 1 says factor. And this is from 9.1, if you wanted to know. And in 9.1, we either learned GCF, difference of two squares, or maybe a trinomial. So on this sucker, let's see if there's a GCF. On this sucker, I think you can divide both of these by a 2. So I'm going to say the GCF is 2. But then that's not the answer. I have to write down that 2, open a parentheses, and write down what's left over when I divide by 2. So if I divide by 2, instead of 2s squared, I now have s squared. If I divide by 2, instead of negative 2f squared, I just have minus f squared. Woohoo! Okay, and if you look at this answer choice, it's not a multiple choice, so you kind of have to know what you're doing. Okay, then next we see that this sucker is a difference of two squares, and it's called a difference of two squares because there's a minus sign, and the minus means different. The two squares means there's tiny 2's in the airs, and there's 2 terms. And the way a difference of two squares breaks up is it becomes 2 sets of parentheses multiplied together. So this one set of parentheses turns into 2. And that GCF of 2 that was in the front, he just still hangs out in the front. Okay, and the difference of two squares looks like something plus something and something minus something. And everything in these parentheses are exactly the same. So we have to ask ourselves, what multiplies with what to give you s squared? And the answer is s and s. Then you ask yourself, what multiplies with what to get you f squared? Well, f and f. Yeah. If I would have had maybe s squared minus 9, then that would turn into still 2 sets of parentheses with s's at the front, still with a plus and a minus. But instead of a letter at the end, we would ask ourselves, okay, what times what gives you 9? 9 and 1? Yeah, sure, but it has to look the same in both sets of parentheses. So the only other thing that multiplies to 9 is a 3 and a 3. So I would put 3, 3. So our problem had a letter in both spots because we had letters to begin with. But if you have just a naked number, you take the square root of that and write it in the parentheses. Okay, so done with number 1. Number 2 is also from 9.1. And I think, Michelle, remember we did one of these in the Zoom and it was real difficult and it took forever. And I said, I'm not going to put that on the test. Well, I looked at the test and that difficult thing is not on there. It's just this easy one. So, woohoo. Okay, so we have b squared minus 18 minus 3b. And it says factor the trinomial. Well, since there's a 1 on that b squared, this is going to be really simple and it's not going to be crazy like the one I did in the Zoom with Michelle. So first we're going to start with 2 sets of parentheses. Yeah. Then we ask ourselves, what multiplies with what to give you this first term, b squared? Well, what multiplied with what up here to give you s squared? S and S. So what multiplies down here to get you b squared? B and B. Yep. Okay, good. Then, to figure out what the numbers are that we're going to put there, we kind of have to do some thinking. We have to add to the middle number, and we have to multiply to the last number. Well, let's look at our problem. Our problem says b squared minus 18 minus 3b, but that looks kind of awkward because the naked number is usually at the back end. So let's just rearrange this. Let's put b squared, then the minus 3b, then the naked number at the back end. Now that everything's in the correct space, we can say that negative 3 is what's in the middle, and negative 18 is what's on the last. Okay, now we're going to draw a little like factor tree, sort of, and we're going to write down numbers that multiply to negative 18, like 9 and 2. Maybe negative 9 plusative 2, or plusative 9 negative 2. One of them has to be a plus and one of them has to be a minus because that's the only combinations that multiply up to a negative number. Okay, what else multiplies to 18? Maybe negative 6 and plusative 3, or plusative 6 and negative 3. Or what else multiplies up to negative 18? Negative 1 and 8, plusative 18, plusative 1 and negative 18. Yeah, okay. Wow, so many combinations. But I need the combinations that is going to add to negative 3. So let's try adding them. If I add negative 9 plus 2, I spit on the paper, that gives you negative 7. That's not what we want. If I add 9 plus a negative 2, that gives you plusative 7. That's not what we want. If I add negative 6 plus 3, that gives me negative 3. Oh my gosh, that's what we wanted. That's what we wanted. We wanted to add to that middle term. So these two numbers that multiply to negative 18 and add to negative 3, we're going to put those two numbers in the parentheses. So minus 6 plus 3. Woohoo! Woohoo! And if you want to check yourself at home, you could multiply this out and see if you get the original problem. So if I wanted to check myself, I could say, let's multiply this out. So if I multiplied it out, b times b is b squared. B times 3 is plus 3b. Negative 6 times b is negative 6b. Negative 6 times plus 3 is negative 18. And then I see the b squared that I started with. Woohoo! I see the negative 18 that I started with. Woohoo. But what about that negative 3b that I started with? Is that what this is? Well, sure enough it is. 3b minus 6b is negative 3b. Holy poop, that's what we started with. It's kind of rearranged, but since it's what we started with, just a rearranged version, that means that this b minus 6, b plus 3 is the answer. Woohoo! Okay, let's do one more. I kind of made the picture a little bigger because my eyeballs are old. Okay, and let's not look at this old picture because when I went to get the picture, it changed. Okay, so first, this one was kind of giving some of us problems on the homework just because of this weird straight side-to-side piece, I think. So first, I think I'm gonna label my X and Y axis. I'm gonna like highlight them because this picture is horrible. I'm old. Okay, so I'm gonna maybe like trace over the Y and trace over the X because I can't see what's going on. Okay. All right. And then right here in the middle where that X and Y cross, that's the X value and the Y value of 0. Okay, so let's look at what this problem is asking for. This problem is asking for the limit as X approaches 1 from the left, the limit as X approaches 1 from the right, the limit X approaches just 1, and f of 1. Okay, so this first sucker, when it says 1 and then a little negative in the air, that means the left of 1. So let's find when X is 1. Here's 2, so 1 must be right here in the middle, okay? So here's when X is 1, and now we're gonna label the part of the curve that's to the left of it. So here's 1. My curve is this weird straight side-to-side piece. You can barely see it. And that's the part that's to the left of 1. Okay, then part B asks for the the limit as X approaches 1 from the plus. That plus means right. So we go to 1 on the x-axis, here she is, and we look at the part of the curve that's directly to the right. So this little piece that's going down, that's the right. We don't look at this part that's going up to the right because it's not directly to the right of this 1. If this piece wasn't here, then I would be looking at this top right piece. But we have to look at the piece that's directly to the right of 1. Okay, then for X approaches just regular 1, we got to consider both. Okay, and then for f of 1, that's where we write whatever the y value is of the closed hole or the solid curve. Yeah, okay. So let's start on part A. It's saying as we're getting closer and closer to X is 1, so here's when X is 1, and as I'm getting closer and closer, coming in from the left, what's the Y value when I reach this X equals 1? And it looks like there's a point of to the right 1, up 2. That's your X and your Y. So we were supposed to be finding the Y value as we get closer and closer to X of 1 from the left. And we found it. The Y value is 2. Woohoo! Okay, now let's look at the Y value as we come in from the right. So as we approach X is 1, right here, from the right, it's asking what is our Y value? So from the right, we land at this same point, and the Y value is 2. Okay, now for X approaches just regular 1, we consider both. So since my previous two answers were the same, that means the limit as x approaches 1 is that same thing, 2. And it's 2 because the left and the right matched. If they were different, we would put does not exist. Okay, now let's look at this sucker, f parentheses 1. It's still asking for your y value, but it's asking for your y value of whatever has a closed hole or is a solid piece of the curve when x is 1. So this is still describing x is 1. So let's go back to where x is 1, right here. Let's find the piece of the curve right here. And if you look at this point, you can't really tell, but there's no open hole. An open hole would look like this little baby. It's hard to tell on your homework, but there is no open hole. It's just solid right there. It's a solid curve. There's no hole there. So since this is a solid piece of the curve right here, I'm going to put the y value, which is 2. Now, let's say I had an open hole right here, and the solid piece, and the only closed hole was somewhere up here. Then I would write down the y value of this closed hole. So here at 1, 2, if it was an open hole, I would not write down the y value for f of 1. I would not do that. If it was an open hole, I'd have to look up and look down for a closed hole and write down whatever that y value is. But that didn't happen on this problem.